let's just label this factoring completely. Even though, yes, we will be kind of laying it hard on the quadratics, but factoring completely is a big deal. Y'all remember some of the factoring completely steps? We said, factoring completely steps involve what? We want to make sure we have descending order, So put it into descending order if it's not in descending order. And what that means is this. Here's an example. Okay. Of course, I wrote that. Okay, so for example, and look, the directions, pretty much all the directions that you're going to see today, or unless it's a word problem, would be this: factor completely. Okay? Okay? So that's where I go with it, because if you factor it completely, it is completely simplified as well. Okay? And you might see simplify and your directions. These kind of are basically the same thing, these two directions. So an example of descending order, you may be given something like this: minus 2 plus 3x squared minus 18x. Okay, and so I might say factor it completely, or I might say simplify. And what you're going to start to do is you're going to put it in descending order. So we're going to find the term with the highest exponent on x, and that would go first. So we want a countdown of those exponents. So see, there's a 2 here, so now we want just the x term, right? Minus 18x. And then the minus 2 goes on the end. This is that form, that basic form of quadratics, okay, that usually you see, okay? And so this is that descending order we're always looking for, okay? And it's at this point we would go into the next steps of factoring. This particular one that I put up here is not any, this is done. It's prime. You won't be able to factor it any further, okay? So we would call this a prime trinomial. By the way, put a little note. A prime trinomial or prime polynomial cannot be factored any further, okay? So we'll say they are factored form, really, is what you can really put, but they cannot be factored any further. Okay, any further. All right, so you wouldn't be able to open the 2 sets of parentheses and put 2 binomials. That would, you can't take this any further. There's no factors of, say, -6 that would, let's see, have a difference of 18. And what I just said, that phrase I just said, that factors of 6 is the whatever, that's the AC method that I'm going to teach you guys in a little bit. It's a little foreshadowing there for you. Okay, so moving right along, after descending order, what's next? Okay, so once you have it in descending order, we want to look for a common GCF factor, greatest common factor of all the terms, right? So we would factor out a monomial factor. So factor out, let's say, the GCF. We would like to have the greatest common factor, right? Common factor. From the terms, okay? Of common factor of the terms. Let me put this, all terms. Okay, so let me give you a little example of that. Okay, this would be a good warm-up for us too. And let's say we have maybe something like this, okay? And I might say factor completely, okay? All right, and your example would look like this. Let's see. Let's say we have something to the effect of 3, open parentheses, 2x minus 9 squared. And let's say we have x cubed y squared minus 6, and then let's have 2x minus 9, and that's it. Okay. As this problem is written, there are two main terms, okay? And I'm going to highlight them, okay? The first term as this polynomial is written is here, okay? So that's your first term, okay? And the second term is actually a negative 6, 2x minus 9, okay? So these are the two little areas we have to go look for common factors. Now, they don't have single x's and single y's, but there's a binomial in there that contains an x, right? If you expand your view a little further, let me show you what's going on here. There's what we would call a common binomial factor. It's bigger here. Okay. So look in the second one, we see this in the parentheses, this 2x minus 9. Okay. And in the first one, you also see 2x minus 9. We call this, and let me put that note, important for you to know this, it's called a common binomial factor. So far we've had a common monomial factor, right? For example, we had, let's see, if you had a 2x squared minus 3x, why, we could take out the x, right? That's just an example of step 2, right, where we would have 2x minus 3 left over, right? That's a simple little example. Okay, but let's take a look at this. Okay, we can factor out what's called a common monomial factor. Okay, let's write that. A common binomial factor. We're going to start treating these binomials, like 2x minus 9 here. We're going to start treating those guys like the whole thing has to match. It's a number. It would be like if I put an x inside the parentheses instead of 2x minus 9. Or if I put a z in there or something, another different variable. We can factor it out. Okay? And so let's go for it. Okay, let's see what we would do here. Okay, we would kind of take this to the next step. Give me some room. Okay. Go here. So we would do that. We would kind of, I need a pen. Okay. So what we want to do is we want to write the common factor. But you know what I need to do as well? Look at the 3 and the 6. I'm forgetting about the 3 and the 6. Out of the 3 and the 6, what would I factor out? Don't forget about the numerical part. We would factor out a 3, right? So let's take that 3 out. Okay. All right. So we want to take out a 3. And then we also want to take out our 2x minus 9. To what power? Look what we have. We have one that's squared and one that's a single, right? It's got a 1 power, all right? Single power. What do we do if it's just x? We take out to what exponent? We take out to whatever the smallest exponent is. So we're only going to take out to the first power. So we want to filter this out, what I've written out here so far. And what I'm going to do is open up parentheses for my leftovers, my quote-unquote leftovers. So I'm going to come on the side over to the right, and I'm going to take each term, and I'm going to divide it by that value, what I wrote here out in the front. Because if you remember, that's kind of what we do on the side. You know, we want to take, this is just my scratch work. So let's give us some room. So if I take my scratch work right here, okay, I'm going to write it, it's like in a light gray color. Scratch work. Maybe you need it to be a little darker, probably. Okay, so, yeah, here I am. Okay, so we want to take 3, the first term as it's written, as it's given to you. 3, 2x minus 9 squared, x squared, y, x cubed, y squared. And I want to divide out what I'm trying to factor out. 3 and 2x minus 9, okay? So what cancels out here? We have our 3's that are canceling. Okay, these guys cancel. So this single 2x minus 9 that I'm factoring out will cancel one of the ones that are in my numerator, right? Okay, and so what's left over? So watch, let me highlight what I just did there. Okay, and get rid of that. I'm sorry, my iCloud, yes, my storage is almost full. So look here, this is what I just did with the, it's a little 2 minus 1 because this guy in the denominator canceled one of these. So you go up and you subtract it there. Okay, and so back to the drawing board here. Okay, let's get back to here. So now what's left over is what? Let's see. We have 2x minus 9. Oh, you can. Too dark. Sorry, too light, excuse me. 2x minus 9 in parentheses, right, to the first power because of the 2 minus 1. I'll put a little 1 there just to remind you. The x cubed y squared did not cancel with anything. And everything in the denominator canceled on purpose because it's what we're factoring out. So this is what's left over from the first term there. Okay, so let's go write that in. So we're left with, excuse me, and I'm going to put that in, I'm going to put a bracket out there. Let's see. I need to make a bracket. Excuse me. All right. So we're left with 2x minus 9 here, and then x cubed y squared. And now we have to do that same thing to the second term. So we'll have minus what? Filter out the 6 and what's left. No. Okay, let's kind of go here and give it a little scratch room for our scratch work. This is a good warm-up problem, huh? Okay. So look, here we go. Get my bearings here because I'm writing in gray, can hardly see. All right, so we'll have the 6, 2x minus 9 to the first power. Okay, 2x minus 9 to the first power, and we're factoring out, so you divide that off by whatever you're factoring out, which is the 2x minus 9. Notice the 3 goes into itself once, into 6 twice, right? And the 2x minus 9 is just cancels itself out all the way. Okay, so we're just left with a 2 right here, okay? So that's it. We're left with a 2. And pretty much this is done, okay? So you can factor out to the front a binomial factor, okay? So I'm going to do some more examples like this. Probably not this ugly looking in the end, but this is done the way it is here. This is done. Won't come out that ugly though. They do exist, and so that will help some of you with some of those problems. So let me say I have a questions box. Person, let's see. Eek, oh no, I got rid of my questions box somehow. I can't believe I just did that. Okay, wonderful. All right, hold on, guys. I just X'd out my questions box. I love it. Let's see. Let's bring it back. Here it is. I got you back. All right, so I thought I saw hands up. What's up? Any questions in the questions box for me? Let's see. Jennifer had a hand up. Jennifer, do you have a question? You want to talk? Hey, I can hear you, Jennifer. You're live. Your mic is on. Do you have a question for me? Nope. Okay, I'm going to mute you out. I'm muting you back. Okay, I thought you had a question for me. So I'm going to keep going. Okay, I saw a hand up, so I was going ahead and answering a question. If y'all would rather say a question too, don't bother. I mean, don't hesitate to ask me to turn the mic on for you. Okay. All right. So here's this. Now let's kind of go here. So we're there. Let's kind of go back over this. So we have first descending order, right? All right, descending order. Secondly, we want to factor out the greatest common factor of all the terms. All the terms have to have that factor, okay? That's very important. Thirdly, right? Once you filter out a greatest common factor, we had something else. I'm gonna put this in a separate step right here, and just to kind of help you with this, I think it'll help you keep it a little simpler. It'll help eliminate error. But thirdly, if the leading coefficient is negative, okay, if it's negative value you have in the front of your polynomial, you want to factor out a negative 1, if you will. Okay? Okay, you can say this, you can factor out a negative 1, okay, or what you can do is say, I want to take the opposite. You know, if you factor a negative out, I'll show you how that would turn out, what that would look like in a second. Let me get rid of this stuff. So an example of that would look like this. It's very important to have a positive leading coefficient when you factor the trinomials that we're going to look at in a bit. Okay? Okay? So let me put that example right here. Okay, so let's say I have this. I might have a negative 3x squared plus 6x plus 6. Okay? And so when you go to factor this, you see that they all have a factor of 3, right? And we have the descending order. We kind of go to looking at all the terms to see that they have a factor of 3. But what you're going to eventually do is say, oh wait, look at that negative right there on the front, right? The negative sign on the very first coefficient of my polynomial, right? What is the coefficient? The very first coefficient is now a negative 3, as it is written. But when we go to do the skills that we use to factor trinomials, we need to have a positive leading coefficient. Okay? So keep in mind that, you know, you do want to factor out a negative along with whatever else you're having to factor out. So we'll take a negative 3 out, and we'll write our leftovers into a set of parentheses. And now, once I filter out a negative 3, what's left over? X squared, positive x squared. Remember, you're taking the opposite. In addition to taking the 3, right, dividing everything by 3, we're also taking the opposite. So we'll have a negative and another negative here. So what's left here is this 2x and then another 2. How do I check it? My factorizations, how do I check it? I go ahead and redistribute, right? Distribute these things back in, right? Whatever you factor out, distribute it back in to check it, right? FYI, okay? Back up. So to check your factorization, just remultiply. Looks like it's raining, okay. Remultiply. Okay, and of course, if we would do that, if we wanted to check this one, and I'll try and make this kind of quick. Why do I keep doing that? Sorry, guys. So negative 3x squared is 2x minus 2. So we want to just distribute the negative 3 back in to check it, right? See if we get, or whatever was the original problem. Negative 3x squared. Negative 3 times negative 2x plus 6x. Negative 3 times negative 2 plus 6. Okay? So we do get our original trinomial, and so that's good. Okay, that means we factored that correctly. Now, this trinomial, what's left over in my leftovers, remember last time I called the stuff that's left in the parentheses after you factor out, if you see this, I'm highlighting it in like the blue highlight. This is what I'm referring to as leftovers, by the way. You always want to check your leftovers to see if you can factor it any further. Okay. You know, so, Okay, so remember that. So let's move to the next one. Okay, so we want a positive leading coefficient. We want to make that happen by factoring out a -1. Is it raining? Excuse me, guys. Yes, it's raining. Okay, I have to pause our video to go close the windows of my car. Okay, isn't that nice? Okay, so let's see. I'm going to pause for a second, you guys, to go close the windows of my car. Okay, so let me stop this recording for a sec. Okay, so back to lecture 11. So here we are. Where were we? Let's kind of just review really quickly so that you guys can be back on track here. Steps of factoring. We want to make sure we have descending order. We want to factor out a common factor, a greatest common factor of all your terms, including binomial factors, right? You can have a two-term factor, like in this example here. And then if the leading coefficient is negative, you want to factor out a negative as well, right? As in this example here in the bottom right of the screen. Okay? Because when we go into factoring the trinomials, we want to make sure you have a positive leading coefficient. That will make everything doable if it's even possible, if it's possible. Okay? And so let's go on then. The next thing you want to do, once you have that greatest common factor, that monomial factor, or binomial factors factored out to the front, okay, then you check your leftovers. So that's kind of the step I'm writing here. This is my real generality. You want to check the remainder of the polynomial. Okay, the polynomial, let's see the factored part. In order to factor completely. Okay, and the remainder, by remainder I mean the leftovers, okay? In order to factor completely. Because you may have your trinomial at that point. You never know, okay? So this is where we would kind of go into using our skills to factor trinomials. Quadratics is what I'm talking about there. Trinomial / quadratic factoring. We may have to go into other special forms of factoring or something like that. And we'll talk about that in a bit. So this is where you check for all the other types of factoring that we're going to take a look at. So let's kind of move on to that then. On that note, let's talk about factoring these let me get the homework out so I can kind of make sure I have good examples for y'all. Let's talk about these trinomials, factoring these, okay? And I think that to be that big. Okay, here we are. So here are our trinomials, okay? And I have these examples out for us. Let me kind of get my pointer here. All right. So let's look at this. Determine the value of t. I'm up here. Determine the value of t in the factors of the following quadratics. Okay? Let me do that. Okay? So I'm right here. Okay? So I'm not going to do all of these. We're not going to have time to do them all, but I'm going to pick a few that look interesting for us. Okay? So what they're doing here is they're getting you to work with the different steps of, let's say, FOIL. And so what I'm going to refer to when I say first, outer, or inner, and last, if you hear me say that, I'm right. I'm going to refer to the steps of FOIL. And so, so what we're doing when you have a trinomial you need to factor is we're trying to lay the factors out as though we're unfoiling, like we're going backwards in the FOIL process. And that takes a little trial and error. But once we do this, these couple of little exercises, I'm going to show you how to have a lot less trial and error. Okay? All right. So let's just take a look basically at B, this part B here. Okay? Let me make this here. So this is the one I'm looking at right now, B. Let's look at x squared plus 8x plus 15. And what they've shown us is a factored version of it, okay? And they're wanting us to figure out what is t, okay? So they're saying to find that missing factor. So we're looking for t, okay? And so what we're supposed to do is say, okay, first, let's check it. This is what I would suggest you do is really what I'm saying. First was what? X squared, right? We can kind of go this way with it, okay? X squared was our first term, our first multiplication, right? FOIL. Okay, what's outer? Outer would be what? T times x, right? Just go ahead and do it the way it is, right? Plus t x. Okay, we don't know what t is, that's outer. I is inner, that's 3x, right? Just kind of going over the FOIL with it. And last is 3 times t. Okay, plus 3 times t. Well, what is t? Okay, we're looking at this. Look at 3t. And look at the original problem over there. What would t have to end up being? 3t, the last multiplication, would be 15, right? So we can find t on that part of the multiplication. So it could come on the side there. Okay, so we can say 3t is equal to 15 and solve for t, just like that. So t must be 5. Okay, are there questions about that? That's pretty simple. But this is a type of thinking that you need to start doing to be really successful with factoring these trinomials. All right, let's look at another one. Let's kind of just check out one more, okay? And so let's look at C. The reason I want to look at C is because the signs are going to be different now. Now we have a plus and a minus in between our binomials, okay? One's plus and one is minus. So here our missing factor is t. It's kind of in the same position. It's going to be a negative number this time. Okay. So but what we can do is just kind of lay out the FOIL just like we just did. First is what? Of course, x squared. Outer is going to be what? Negative tx. So negative tx. Inner for plus 4x, right? Plus 4x. Okay, and then last, finally, usually it's going to be on your last multiplication if you can do that. You'll do these. You'll be able to figure out what that factor is. The final one, the last, is, will be minus 4 times t. Okay? So when they multiply, the whole thing is negative. So look, what is that then? Okay, if we go back to that original one over there, that last multiplication should be negative 4t should be negative 8. So look, negative 4t is equal to negative 8. Okay, so if I divide by negative 4, okay, on both sides, right, what will t be? Okay, so t then will be positive, right? Negative over negative is positive 2. So into the t slot is where we'd put a 2. Okay, in other words, what this would end up looking like would be x plus 4, x minus, and inside t we stick a positive 2. Be careful, if we would have solved t and it would have come out like a negative 2, then it would be minus a negative 2. Be careful when you're plugging in for your variables, okay? So by getting a positive 2, we did get it right. In case some of you are worried, or maybe you thought you'd see it come out to be negative 2, but no. As the problem's written, that's how you need to work it. So it includes any time, including this type of stuff. When you go to plug something into a variable, put that number exactly as it is into parentheses, okay? So be careful with that. Okay, so it does work out. Let's take a look at one more. We can look at E, just to give us one more of these. You have some that are similar to this in your homework, so I thought these were good to get you started thinking this way. And let me hurry up and get this one out here. You'd see first is x squared, outer is negative tx, enters minus 8x, but the last multiplication, this, and I'm just going to skip straight to this negative 8 times negative t, right? Okay, be careful with the signs, should be what? 24, correct? Positive 24. Now, negative 8 times negative t is still going to boil down to a negative times a negative, right? So which is still going to end up being positive 8t. It's equivalent. Okay? So that's what I'm looking at, the negative times this negative, not necessarily 8t. So two negatives multiplied will give us positive. So now let's solve for this t. We divide by 8, we'll get what? We'll get t is 3. So t is 3. So let's plug that into that where the t is in the problem and see what we get. Let's practice it and see what we get. We'll practice our FOIL and see what we have there. We would have x minus 8 and then x minus, and it's positive 3, so we just put the 3 just like it is. So let's multiply it up and see what we got. Okay, so first is x squared, so that checks. Outer is negative 3x and inner is negative 8x. Do those two things add up to negative 11x? Yeah, right? Negative 8, negative 3, tack an x on, so that checks out. And then finally, negative 8 times a negative 3 is positive 24. So this guy works out. Okay? All right. So now they want you to go through, and then this other part here, the second part is go through and put the right sign in. So that's going to help you get your sign rules. And so I don't want to go too much on that one. I'm going to go to the next little section and we'll get to the sign rules in a bit. Okay? Let's go here. Okay, I'm going to go to this part 4 right here, okay? Okay, let's see. Let's take a look at, let's start with B. Okay, I'm going to take a look here. X squared minus 7x plus 10. Let me hurry up and get to some that look like your homework too. Yeah, okay. So we're moving up pretty quick here. All right. Oh, sorry. I think I just unplugged my USB, my tablet. Okay, so to do this one, okay, we're going to open up two sets of parentheses here. All right. Alrighty. Now, see, notice we have this one coefficient. There's nothing on, or nothing pictured on the front of x squared. This helps us get used to the format, okay? In other words, you can open your two sets of parentheses and just show up an x in each one in the beginning. And then you can ask yourself, what factors of 10? What are factors of 10, right? Because we don't have an a on the front of x squared. This is AC method, and you will get used to this. What are factors of 10 that, let's see, that subtract, no, I'm sorry, that add up to 7. I'm not going to worry about the signs. That sum to 7. Okay, so let's see, that have a sum of 7. That have a sum of 7. Okay, so let's first look at factors. What are factors? These things are multiplied. So I'm looking at, like, say, 1 times 10. I'm looking at all the factors of 10. Okay, and then are there any more? I have 1 times 10, 2 times 5. There's no 3, there's no 4. If we go up to 5, we're starting over and repeating ourselves. So this is all I need, is just the pairs. Now, do any of these pairs that I've written, like 1 times 10, 2 and 5, do they have a sum of 7? Well, yes, they do. Look at the 2 and the 5, right? These guys answered the AC method question. Okay? Where did I get the 10 and the 7 from? Okay? We want to look at if there's ax squared. I'm back at the problem. I'm on the left side here. This is the format of a quadratic trinomial. Notice we have ax squared, and the c is always on the end, right? So you take the a and then C and multiply them. Okay, that's why we call this the AC method. We'll kind of come up here to the top, all right? I'm going to give you a generic format for the question I've been asking. If anyone's ever, you guys come get help from me, you'll hear me saying the question a lot. So A times C method, okay? It kind of just helps you to suss out the factors from the trinomial to be able to put them into the binomials, to factor them out. And so we usually say this, okay? We ask this question. We say, what are factors? And you can kind of insert the correct numbers into this little generic version right here. What are factors of A times C, right? So whatever this is going to be a different number each time, okay? That have, let's see, that have a sum. Let me say a sum, or it could be a difference, okay? And I'll show you how you can tell what it's going to be in a minute. Have a sum or a difference of B, whatever the B term is, okay? So there is the basic question of the AC method, okay? This is what you will ask every time you go to do one of these problems, okay? So here it is, AC method. What are factors of A times C, okay, that have sum or difference? So how do we tell, or do we say sum or difference, Karen? So what's the deal? Here's the deal. For this problem, then I just kind of paused for a second from this problem. Notice the very last term, okay? This is where you tell. Two things that are the same. We multiply two negatives and we get a positive. If we multiply two positives, two plus positive things, we get a positive. So the very last term, if that is positive, that's when you say that have a sum of B, right? So if your C term is positive, the very last term, positive, you say sum in the question, okay? So if you have a plus C on the end, if you notice I'm highlighting underneath the word sum over there, okay? And then on the, if it has a minus C, if you have a C subtracted off the end, that's when you say difference, okay? All right, so that's that. So for this one, we're saying sum of 7. So let's go back into the problem. What do we do with the 2 and the 5? Okay, the 2 and the 5 give you a way to bring in the factors that are outer and inner. So you want to have a 2x and a 5x, right? A positive 2x. Excuse me, not that. A negative 2x and a negative 5x, right? Because the 7 has to be negative. So we want to put in a minus 2, minus 5. You're going to have, I really at this, oh, that should be fine. Really, you got to play with your signs to get used to that. It's hard to really just teach you guys in 10 minutes, but you have to play with your signs to get used to where to put the signs. You must check these answers. There's no way really to get around learning this well without checking your answers, okay? Let's do one of these down at the bottom that has something on the front of it. We'll do a couple of them, and then we'll kind of try to get as much as we can fit in for the next few moments. Okay, so we'll look at the little note here. Let me kind of make sure this is background too, so we can have room. It'll let me write on it. Make it bigger. There you go. Okay. So let's take a look at this note here, okay? Excuse me. Y'all have questions, by the way, anybody? This is right here, what this little note up in the right is telling us. Remember to take out the GCF if it's possible, okay? Including the negative, right? We want a positive leading coefficient, so be careful. The descending order is important too. Okay, I don't see any negative leading coefficients, so we're good there. But let's kind of Let's go through these. I kind of keep forgetting to look at the questions box, so please do those. Ask some questions, okay? I don't want to go on too far if you guys are confused. Yes, I can. Okay, yeah, sure. That's the one with the binomial factor. Okay, we're going to look at one like number 4. I can go ahead in the book and find one soon. Okay, let's take a look at one or two of these, though, and then we'll look at that really soon. Let's try, let's see. Let me find something in here that's going to look something like what you guys are going to deal with to some extent. Okay, yeah, I see. All right. Let's take a look at, let's go here first. Okay, C. All right, so let's take a look at C. I'm going to highlight some. I want you guys, you can go ahead and try them. Once y'all start, I'll highlight a few, just to kind of not have to choose so much. Be choosing the whole time we're here. Okay, I'm going to scroll up a little bit. We'll look at this one, then we will look at, let's see, okay. Look at K. I want to look at one that has some factors. Yeah. Oh, look at these. Okay. Let's go ahead and do these. We can do more of them if we have time, okay? I'm going to do I too. That's one I was looking for right there. Okay, so let's take a walk through these. Look at C. All right. AC, okay, AC is this. What? 2 times 3 is 6, right? Okay, so we want to first just kind of quickly scan and get the AC question, right? So we want factors of 6. We're looking for factors of 6 with a sum, right? Because of the plus sign there. Sum of a negative 5, right? You can say negative 5. Okay? So let's take a look. All right? So let's kind of write those out. I'm going to kind of go do these right under this here on the right. Okay? So 6. Okay. Factors of 6. Just list out your factors of 6. You got 1, 6, 2, and 3. Okay? And so also, if we want a positive 6, could we have negative 2 times negative 3? Because these guys would add up to negative 5. You see what I'm getting at with the sign thing? It kind of comes as you kind of start looking at these more. Okay, Viv, I'm coming to that in a sec. Let me finish this one, and I actually will look at that one. Okay, hold on a sec. I'll answer that in a bit. Okay, so what happens here? Open your 2 sets of parentheses. Okay, and we're just going to put 2 as prime, so with 2x and x. 3 is prime too, but we want to be careful. You want to kind of draw, you can draw your little lines to start. Look, this one has to be a negative 2x. This is where our AC method comes into play, by the way. So we have negative 2x that we want for one of those for outer. And we also would like to have a negative 3x. So we need to put a 3. We have an x already in one of the slots, so we need to put a negative 3 here. See the negative 3x? And then negative 2x. So here we need to put minus 1. Then we check it, right? Okay, so AC method answer tells us how we want to lay out the outer and inner factors, okay? And then you just put them in there, put the factors in there, and check it. Make sure you check. You don't just assume you got it right the first time. That's definitely something. If you guys want to write these down to practice or something, let me go through I with y'all quickly and answer those other questions. I is one where you need to factor out the common monomial factor, okay? All of these are divisible by 3, right? Especially 3. So we need to take out that common monomial factor, okay? what's left over when I take a 3 from the first term? Okay, we have a 9x squared, right? If I take a 3 from negative 18, I should have minus 6x. And then, of course, take a 3 from 3, and we're left with 1. So what we have here is actually a perfect square trinomial. That's nice. In other words, we look at the front and you see perfect square. And remember that 1 can be a perfect square, cube, perfect, whatever you need it to be, by the way. These trinomials factor out just like any trinomial. But if you see this perfect square on the front and on the back, just try the square root first even, okay? 3x. You guys should be kind of seeing, you've seen these enough that you should be getting used to your signs. If you see that you have a plus on the end, they're the same, right? These two guys are going to match if the last number, the constant term, is positive. And what they're both going to be is the middle term sign, right? So this does work out, right? I check it. Negative 3, it's negative 6x. I'm going to let you guys check it a little like slower than that. I'm running out of time. So I don't want to like miss anything. So look, you can always write these like this, by the way. 3x minus 1 squared. Okay, if it's twice there. Let me kind of look at some of your questions right here before we run out of too much time. I'm going to put more of this kind of stuff online, and I'll even look at, if I don't get to anybody's questions, but I think I'll be able to get to all your questions real quick. Okay, the first question was about number 13. Okay, Megan, did that first example I did earlier kind of help you a little bit? I hope it did. You go to a blank piece of the page. Hold on a second. Let's see what I gotta do here. That. Go here. Let's do that. Okay. Make some room. Okay. All right. Okay. So if I have this, let's say I have 3x plus 2 minus 4x plus 2. Okay? This is like a real simple example of that. Okay? Let's see. Cool, I'm glad. And this might help also one of the other questions I had earlier too. Let's see. This might help on number 4 as well. Okay, so 4, whoever had Stephanie, I think you had the question on 4. This one helps with that as well. Okay, you can expand this to however many terms. Okay, if all the terms have the same binomial factor, this will work. You'll notice x plus 2 is in parentheses, right? It's its own little animal in each term. There's only 2 terms in this one, but it's the same thing whether you have 2 or 20. If all the terms have this factor, just like it was a z to whatever power, you want to factor out the smallest exponent. Okay, so if we're factoring out an x plus 2 from each term, the smallest exponent is 1, right? What's left over, right? This guy comes out, and I'm left with, in parentheses, a 3x for the first term, right? It's this guy. And then a what? In the second term, we're left with minus 4, right? That's that guy. And that's it for this one. Okay? So, yeah, this looks like a trinomial factorization. It is, actually. There's another way I want to show you guys. Not right now. I don't have time right now, but I can show you guys in a video of how to use the AC method to factor trinomials with grouping. Okay? Let's see. Let me try to get another one similar to what you guys are stuck on. And let's see. Okay. Let me see. I got something for y'all. There's this one too. There's an area. Let me make sure I'm not getting to all these questions. Let's see. Or is there anything different though about anybody had a different type of problem that I'm not seeing yet? 12 is, oh, the 12, yeah. Which is following as a factor. Let me hurry up and look at 12, and I'll do another binomial one, okay? I don't want to run out of time. So Which of the following is a factor of this? Okay. So what you can do here is just start factoring it, I guess, like it is. Do your steps, y'all. Perform your steps of factoring. Let's see. I'm going to do something very similar to it, just to kind of give you guys an example, okay? This is an example. Remember, it's always factor completely, by the way. And this might have to be our last one because we're kind of going overtime here. But let me see. Okay. Go here and go there. All right. So, all right, I'm trying to get this example up. All right. It's coming. So directions are to factor completely. And so in this example, we have, let's see. Oh, this one's going to help all y'all. All right, so this one is 5y minus 2, c squared, 3x plus 1, plus, this is a big one, 5y minus 2 plus 3x plus 1 squared, probably, minus 4, 3x minus 3x plus 1. I think that's it. Yeah, that's it. Okay, so this one actually lines up with number 4, you guys. So, and all the others too. The point of this one is there is a binomial factor common to all of them. But be careful, not all the binomial factors are in common. Okay, you have to look out. Let's examine the 5y minus 2. You'll see that up in front, right? That's kind of there. 5y minus 2. Is it in common in all three factors? Let me highlight the factors, the main factors of this problem. Here's your first group of factors, right? I mean, excuse me, your first group of terms. What am I saying? I'm highlighting the terms of the polynomial. Here's your first term, okay? And then here is the second term, okay? So we'll look at that, and then we'll finally, the third term of this one is here. It's negative 4, 3x plus 1. Okay, so the question is there a 5y minus 2 that's common to all three areas? No, right? So we cannot factor that out. That stays put. What about 3x plus 1? If you'll look, there is a 3x plus 1 in each of the three terms. They all have to have that common factor in order to factor it out. So be careful. And what exponent, what power do we take? We take the smallest exponent, which is 1, right? So we just want to write that out to the front, and now we're going to write parentheses and start writing our leftovers. So what's left over for the first, the yellow term, is what? The 5y minus 2 squared. That's it for the first part, right? That's done. Okay? So that's this guy. Okay? And so now for the second term, we can only take out one of these guys, right? Be careful because that's a square. So what's left over? We're going to write the 5y minus 2 again, only to the first power. And now this time we're filtering out one of these 3x plus 1s. That's what we're factoring out. 3x plus 1. So instead of squared, we're writing it to the first power because we took one of those out. That's what's up here in the front. And then finally, minus 4, right? The last one, we've taken that out. Okay, and so let me kind of write those colors out there for you. Okay, so let's see. This is the last one. Okay, and then get this color. I don't know where I got that color from. That's not it. All right, so anyway, you get the point, I think, hopefully. It's this one here. Okay, Any questions so far on that? Let me take a look at the questions box now and make sure you guys don't have any questions left over. Let me see. All right, what you guys got? What else do we need? 12, homework 11. This, okay, the 12. Let me just see if there's anything in there I'm not seeing. But which of the five? Oh, on that one, on number 12. I mean, really, I would go through the steps of factoring. I don't know what else to tell you on that. It's not as bad as it looks. On any of the problems like this, take the longer part of the problem, the polynomial part of the problem, and just start factoring it. Just see what you got. You know, they all have a to some power, and they all have at least a 2, right? Actually, maybe even more than that. But, you know, you go through steps of factoring. That's what I can tell you on that. Let me see. Find any others that are good for that. Give me 1 second. I'll look and see if I have something else I can, another example just to kind of wrap it up for y'all. Let's see. I'll put it on. Okay. I'm looking for a good problem. All right. So, let's wrap it up with one of these. Okay, let me get one out of the homework book for y'all. And so, let's take that one. Okay, I'm going to do this problem. Okay, so let me go ahead and snap that. Let's see, this is what I'm looking for. All right. Okay. Snipping tool. Where's my snipping tool? All right. Okay, I'm coming to it, guys. Hold on. There we are. Okay. Now, snipping tool. Here you are, snipping tool. It's going a little crazy, but I got it. Okay, let's take that. Take that. All right. All right, so here I come, rocking like a hurricane. Here we go. There you go. And here we are. You see that? I got you. Okay, let's take one of these. Let's take E. This problem E. All right. So we're going to look at E there. Okay. Just grabbed it really quickly, so I grabbed everything else with it. So let's take a look at E. And this would probably be a good one to wrap it up, unless y'all want to see F, in which case we'd have to take that negative out. Let's start with E. Maybe we can do 2 to wrap it up. Factor completely, right? Factor completely. What would you do for E? What are we going to do to factor this? We want to look at the 100. This is 100, and that's an L, M, and an N, right? FYI. No pun intended. So we can take a 4 out, okay? Also, we can take L, right? But L is only to the first power, right? So we can take an L out. We're going to take it, not an M. We will not take an M because the second term does not have an M. So no M, right? Be careful on that, okay? Just food for thought. And then we can take an N out, though. We'll take an N. Now, what's left over? Once we take the 4 out of the 100, we have 25. We take that all. We're taking the L out. We're going to have M squared left over. M. The N is gone. We filtered that out. Now, filter out this 4. What's left in place? Remember, when you factor out the 4 and it's what you're factoring out, you're left with a 1, right? You don't have to put the 1 if you have variables, though. So, look, we had an L to the third power, right? We factored 1 out, so we're going to have L squared left over. So the N is filtered out, and this is what's left over. Now, we said to check the leftovers to be sure you can factor some more. Oh, okay, I'm gonna go back up to that and answer your question in a minute, Megan. Hold on 1 second. Okay. So we want to make sure you can't factor again. So we check these leftovers here to be sure. And sure enough, in this one, we can factor this as a difference of two perfect squares. So this ends up looking like this, 4ln. And we have the sum and the difference, right, of the same two values. What's the square root? 5m and L, 5m. Excuse me, this should be minus. I'm sorry. One's plus and one's minus. What I was thinking. 5m plus L, 5m minus L, right? And so that the sum and the difference, right? The sum and the difference of the same two terms ends up being the difference of two perfect squares.